Hello again, YouTube. This is Aphex Techno. This is a YouTube video that I've been planning on doing for quite some time now, and just never really got around to doing it. So this is my attempt at accomplishing that, anyways. Hopefully, in this video, I'm going to cover every Commodore 64 motherboard revision ever made. And starting off with the series here. This is one of the very first Commodore 64 motherboards ever made. This is a revision 326298 Rev 8. This particular board is in a silver label. Well, this is only the bottom half of it, obviously, but this is what you got with an older 64 motherboard. You can notice the CIAs here. They are date-coded 14 week of 1982, which is pretty early. This particular silver label has seen a lot of work done to it. Basically, it's all been done by me. When I got this particular machine, it had a lot of really strange modifications done to it, and I put it back to as stock condition as I possibly could. So now it's mostly original. I'll flip it over here and show you the serial number. That's the serial number of the machine there. Now, as you can see on silver labels, the serial number starts with S. So that means this was a California-made machine. You can actually see it's a little bit dirty there. But silver labels all have the S prefix of the serial number. You see this one's 31145. It's pretty early. They also have the compliance certification sticker here, as well as this FCC ID label. So that's what the bottom one looks like. They almost all have the brass shields in the back of the motherboard. That's another identifying feature of a real silver label. The other two dead giveaways for a real silver label are the green cartridge connector as well as the green power switch here. So a lot of silver labels I see. This is the 7805 voltage regulator. This supplies the 5 volts DC for both the SID chip and the VIC chip. The VIC chip is inside this can here. It's about in this orientation here. I'm not removing this can right now, and then that's the SID chip. This here is the 7812 that supplies the 12 volts for both the VIC chip and the SID chip. The reason this has its own voltage regulator for the 5 volts and 12 volts instead of just using the 5 volts that come in off of the normal power jack here is to essentially cut down on noise and interference. The board has its own 5 volt supply derived from the 9 volt AC supply, basically to eliminate any kind of crosstalk interference or whatever. You know, if there's a bunch of switching noise from the rest of the TTL logic on the board, it isolates the SID and the VIC from any of that noise that may be present. At least that's my theory on it anyhow. I haven't specifically read anything to that effect before, but I would assume that's the reason. But anyways, getting to the details of this particular style board, you'll see this is the CPU chip here. This is your color SRAM, which they have right next to the CPU up here. And you'll notice on the later boards, they've moved the color SRAM all the way down here. But you basically have your keyboard connector, your two CIAs in the same place they pretty much always are, except for the short boards and 64Cs. You've got your 3 ROMs. You've got your basic, your kernel, and your character ROM. You've got your PLA chip and your SID chip. I mean, that's all pretty much as you would expect it, more or less. A note about these PLA chips. The very first style of PLA chip in Commodore 64s was based on the 82S100 programmable logic device. This is one of the very first styles of programmable logic device that were, user definable. When Commodore went to make their own PLA, they essentially copied the 82S100 and they made it mask programmable. I have a whole pile of dead PLAs here. This is a MOS made PLA. It's a dead one because it's a very high rate of failure part, if anyone that knows anything about repairing Commodore 64s would know. And MOS gave it the part number 906114-01. But basically, from what I know, these particular PLAs are essentially direct one-to-one knockoffs of the 82S100. The only difference is they changed a few things in order to make this mask programmable. These particular type of PLAs are what are known as fusible link PLAs. When you burn, or the old term for it used to be blow, when you blow a PLA with the code that you wanted in it, you're actually severing little tiny fusible links inside of the die, whereas this is mask programmable, which that basically means at the time of layout, while they're laying out the chip before production, one of the final masks applied to the artwork design actually defines what this will actually be, the actual logic elements that are present inside the chip. I hope that makes sense. As with all of my videos, I don't go off of a script or anything like that. I just kind of go off the cuff here. So if I make any any errors or anything, I hope you guys forgive me, because I'm going purely out of what's in my brain. So anyways, continuing on with the board here, all of these little things here are all the bypass capacitors for all the RAM chips. Here you have your 64K RAM, which is these 8 chips here. You'll notice these are all Hitachi branded chips, and you can see the part numbers there and everything. Here you've got the 7406, which does a few things. One of the serial port lines goes through it. I think the reset line is supposed to be buffered through it on later board revisions. Here's your 556 timer. This is what generates the reset pulse that resets the system on startup. Because if you actually, here's the reset pin on the 6510. If you put an oscilloscope probe on there and watch it when you turn the machine on, it'll go low for a second and then go up to high as it resets the chip. And that's all done with that 556 timer there. But anyways, continuing on, you got your two 4066 CMOS quad switches here. This does a number of things for the board. One of them does the pot XY lines on the joystick ports. So if you have paddles plugged into one of the joystick port, one of these chips is what handles that. Here's your 74LS257. These are the memory multiplexers. This is what multiplexes the signals coming in for the RAM here. So you've got your 74LS373, you've got your 258, you got your 74LS08, and the 139. You'll see in the later board revision how these have been kind of swapped around. So anyways, this is a quick overview of the earliest silver label 326298 motherboard, Rev A. Alright, next up on the bench here, this is another 326298, but this particular motherboard is from a slightly later 1982 model C64. This board did not come from a silver label, and I performed a few small modifications to this board myself. This is, if they're not silver labels, I generally modify these 1982 boards slightly to make them a little bit nicer to use. One of the ways that you can tell this particular motherboard is not from a silver label is you can notice the cartridge connector here is black, the power switch over here is red. Now this is indicative of a machine with a serial number of approximately, I don't know, between 100 and 200,000 or so. These typically came from early rainbow labels, and my assumption is these boards were merely recycled from the original silver label recall. That might not be true for every one of these later 1982 boards, but in my experience I have seen that quite often. So starting with the modifications that I made, and I've covered these modifications in some of the older YouTube videos on my channel where I focus on these 1982 boards pretty heavily. This is my little reset modification here I've done to the reset circuit, and this allows cartridges such as the Easy Flash and the 1541 Ultimate to operate correctly on these older boards, because there's a significant design change between these boards and the later 250407 boards that have the 8-pin video connector. But anyways, as you can see, because this is a 326298, it's laid out exactly like the silver label board that I just showed, but there are some slight differences. You can see I've exchanged the SID filter capacitors here for the proper values, which is 470 picofarad. Done the reset modification there as well, and underneath this, the lid to the VIC chip can here is resistor R10, and by exchanging that with, I believe it's a 130 ohm resistor, you can greatly improve the brightness of the video output of these early boards. And as anyone would know, these early boards have 5-pin AV jacks just like this, and they only support composite video. And of course you have your standard RF video output there as well, but I don't think anybody really uses that anymore. So anyways, I just wanted to show this board off really quickly, as this is an example of a slightly later 326298 that isn't a silver label. So continuing on with the video, up to the next one. I just wanted to show this off before I crack it open. This is the only one I own like this. This is actually a PAL silver label. You'll notice how the label itself is a thinner material. It's not a solid piece of aluminum like the NTSC silver labels. All of the boards I've showed you up to this point are all NTSC, and most of them will be, but if they happen to be PAL boards for some reason, I'll try to make a note of it each time. So I just wanted to show this off real quick before I cracked it open, because I never actually have showed this on the channel before, but this is the only European PAL silver label that I own. I got this from a good friend in the Netherlands. As you can see, there's the serial number there. It's a West German made machine, WGC11901. PAL silver labels are a lot harder to identify than NTSC ones are for a few reasons. But the reason I went out to the garage to get this particular machine is because this contains a very special motherboard, which I'll show you in just a moment. Okay, here we go. This is a shot of the motherboard. And as you'll notice, this motherboard looks kind of interesting. This particular motherboard is known as the KU14194HB. The strange thing is that this particular series of letters and numbers I've seen on other Commodore boards from the time period. I think this is something to do with the manufacturer. I don't know, but anyways, that's what this board is known as, and that's what I'll call it. So anyways, you'll notice some similarities and differences to the earlier 326298 boards. This board basically serves as an interim or stopgap between the 326298 and the 250407 board. This particular type of board is pretty rare, and they're generally only found in very early PAL European machines, typically silver labels. And as such, they are pretty rare. This is actually the only machine that I own with one of these boards in it. So as you can see, the CIAs, they have date codes of the 52nd week of 1982. But generally, you can see some differences here. The color SRAM is still up here by the CPU. But you'll notice here that the can for the VIC chip looks a lot like the next revision of board that I'm going to show you after this one. But we still have the voltage regulator still in a similar position to the 326298. You'll also notice over here they've added this clever little heatsink arrangement to the 7805. Now, something I forgot to mention on the silver label board I showed you a little bit ago is that I added that later style heatsink to it. I have a couple other silver labels that have the original 7805 here that don't even have a heatsink on them at all, and they run really, really hot. So if you ever plan on actually using a silver label, which you know, you can if you want. I use mine a lot, so you know, but I can also repair Commodore 64s. So, but anyways, if you're planning on using one, I would advise you to add some sort of a heatsink to that 7805. Anyways, continuing on, one thing to note about this particular motherboard revision is unfortunately I can't move this around too much because I have wires connecting the goofy reset switch someone added there at some point. But this is the very first 8-pin video output motherboard that they made, and I'll show you that in just a second. There you go. This is the back of the board here, and as you can see, this has got the 8-pin AV connector, which would go on to be present on every 64 and 128 from here on out. But this is the very first board to pioneer that particular video output that has separated Luma and Chroma signals, which we now know as S-video. Anyways, back to the board itself. Like I mentioned, these are particularly rare and valuable boards. To my knowledge, these boards only ever came in PAL machines, so you're never going to find one of these in an American NTSC Commodore 64. Other than that, they are decent, good running boards. I have no real complaints with it. This particular one happens to have a 6569R1 ceramic VIC chip in here as well. So that's another sort of desirable thing if you're interested in revisions and part numbers like I am. I'm not really sure about this weird fuse. I don't know if that's stock or not with this. Looks like there's some sort of a little blue thing inside the fuse. But yeah, this is the KU14194. And like I said, there's a lot of similarities between this and the 82 board and also the 83 board I'm about to show you. So anyways, let's continue on with the video. Alright, next up on the bench, this is the venerable 250407 motherboard. This is probably the most common C64 motherboard of all of them. This particular unit is a NTSC model, of course, as most of the ones I own are, but I do own a number of PAL machines as well. But this design of board set the stage for all of the subsequent motherboard revisions. You'll notice here, this is the CPU again, the 6510. They've moved the color SRAM, instead of having it directly next to the CPU, they've actually moved it down here. And it's kind of an interesting design by using the double-sided board with all of these vias, how they're passing the signals from the back and the front of the board repeatedly to get it over to the VIC chip, which is underneath this can once again. You'll also notice that the 7805 voltage regulator, which used to be right over here, has been moved down to this area. So now you have your 7805 and 7812 right next to each other. And the 7805 has its own dedicated heatsink now, which this improves things considerably. And since I figured we needed a little mood music, I went ahead and hooked up the PAL Silver label, and I'm having it play a little bit of SID play here while I'm narrating the rest of this video. So anyways, you can tell in this particular motherboard revision, they have the PLA up here in this socket and the SID chip down here in this socket. And that'll become important later when I show you some of the later board revisions. But again, as like the early 82 boards, you have the very similar layout to before here. You've got your 7406, you've got your 556 timer that generates the reset pulse, your 2 SID chips, your 3 ROM chips. There's a lot of similarities here. You can see there's definitely some, DNA lineage going back to the early board. But the thing Commodore was famous for was constantly, as I was saying, the thing Commodore was famous for was cost reduction. They were always looking for ways in which to produce these Commodore 64 boards cheaper and cheaper as time went on. And the other thing Commodore was famous for was their vertical integration. They, of course, owned their own chip producing fab, which everyone knows is MOS, and were capable of making their own microchips. Therefore, they wanted to utilize them as much as possible to save money in their designs. And you'll see as the board revisions go along how they were always searching for ways to integrate components into single chips, reduce the chip count, even make the PCB much smaller. It's really interesting to see how they went about doing that all throughout the years. But again, this is the 250407. There happens to be 3 revisions of this particular motherboard. This one, as you can see underneath this heatsink here, is a Rev B. There's a Rev A, B, and C, at least that I'm aware of. And the only major difference is they moved a few components around. The general layout of the board and the schematic is almost identical. It's just the physical routing and placement of some components has been changed. So if you ever see people talking about the different revisions of the 250407, it's not really that big of a deal. So anyways, on to the next board. Alrighty, next up on the bench here, this is the 250425 motherboard. You can see I'm missing a fuse there, but these are all boards that I tinker around with. They're all in working condition, some are missing chips, that sort of a thing. And I'm always messing around with them. But anyways, you can see this board. There are some striking differences between this and the 250407 that I just showed you a minute ago. Number one being, the VIC chip now has changed orientations. Instead of being vertical here, it's moved down to a horizontal position. And also you see this. This is the 8701 clock generator chip. This is one of Commodore's first major cost reduction strategies on the Commodore 64 motherboard. These boards started coming out somewhere in 1984, I believe. And what this 8701 clock generator chip did is this integrated the functions of 4 separate TTL chips that used to be right around the VIC chip area here. I'll get my chip testing board real quick and show you what that looks like. This is my chip testing board here, and it's been featured on my channel a number of times. And this is a 250407. You'll notice the VIC chip is vertical, once again, as per the older boards. And these are the 4 separate TTL chips that make up the clock circuitry. You'll notice on this particular board I've removed the entire cage that used to surround this and close it in, so that's why I'm using this as a demonstration. But these are the 4 chips here that were basically done away with and integrated into the 8701 clock generator chip. So anyways, continuing on, we can see a couple other differences here. The 556 timer that used to be down here has been moved up here, and the 7406 has been moved up there. I don't really have any good theories as to why this was done, but that's just how these boards are. You'll notice we still have our same 8 DRAM chips here, 4164 64K by 1-bit chips. We still got our 257 memory multiplexers, and then you can see the arrangement of some of these have been shifted around somewhat. You'll also notice the color SRAM has been moved from there back down to here, I believe. Those are your 2 4066 CMOS quad switches. A major thing to note with these boards is that you'll notice the PLA has now been moved from up here down to here. And these 2 chips have swapped positions on this board revision. So if you're someone like me and you're working on lots and lots of Commodore 64s all the time, you have to be very, very mindful of what board revision you're working on, and you do not want to plug a PLA chip into a SID chip socket or vice versa. That's just something to note. So be very careful what socket you're putting a PLA into. But other than that, the rest of the board layout is relatively standard. You've got your 2 CIA chips here, as you would expect, your 3 ROMs, your CPU. Everything's pretty similar. And again, just like the last few boards we've looked at, this one is an 8-pin video output as well. So anyways, generally speaking, that is an overview of the 250425 board. On to the next. Alright, this particular board that I have on the bench now is a revision 250466. This particular board is found in some bread bins, a few, but this board is basically known as the original early C64C long board. This board shares a great deal in common with the 250425 except for one major point. You'll notice here we've got your 8701 clock generator chip, you've got your VIC chip. As it happens, this particular board happens to be a PAL version board. So anyways, you've got your PLA here as well, your SID chip up here, so they've retained that as well on this particular board revision. That's your CPU chip. A note about these funny little heat sinks. I've seen a number of these little bent aluminum heat sinks like this on PAL machines, and I'm pretty sure they're stock. I'm not entirely 100% sure about that, but that's been my estimations this far. This is the major defining difference of the 250466. You'll notice this giant gap area here where you would normally expect to find 8 of your 4164 DRAM chips. On this particular board revision, they have been replaced with 2 4464 RAM chips. So here again, they've consolidated down 8 chips into 2. These are 4464 DRAM chips. These are 64 kilobytes by 4 bits apiece. So 2 of these chips together make up 8 bits of 64 kilobytes. And again, you've got your 7406 and 556 in the exact same place as the 425 board. The CIAs and everything are still in generally the same locations as you would expect them from the previous board. And again, you've got your 7805 and 7812 in the same positions you've grown to expect. Other than that, these particular style boards are there's not too much more to remark about them. Again, these are 8-pin AV output boards. They output lumen chroma signals just as you would expect. These particular boards, though, these happen to be probably my favorite Commodore 64 boards of all of them, for a number of reasons. The main reasons are they still use a lot of the same chips that early bread bins did, and these chips are a bit easier and cheaper to get a hold of than some of the later 64C chips. Now granted, this probably applies more to the USA than Europe in general, because over in Europe it seems like the 64Cs had a bit longer life on the market than they did over here. So anyways, I'm speaking from a very US-centric point of view, I would like to add. The other thing is too, is you don't have 8 RAM chips to deal with, you've only got 2. So RAM repairs on these particular boards are very, very simple. Like, you've only got 2 chips to swap out, and you've replaced all of the RAM in the machine. It's a lot easier than desoldering 8 16-pin chips, putting sockets in. It's just a lot less hassle. But you also have standard TTL chips here, which are still available on the market from all sorts of different places, if one of these happens to go bad for some reason. They're just really repairable, high quality boards. They run very stable, they're very compatible. Like I said, these are probably my favorite boards of all of them. And another thing to note too is both the 250425 and the 250466 motherboards have excellent video quality output, and that's due to the redesigned RF modulator for the most part. And by this point, they had pretty well got the VIC chips figured out as well. So in my personal opinion, you're probably going to get about the best video quality out of these boards. Another reason I love these boards too is they all take the 6581 SID chip. Now there's absolutely nothing wrong with the 8580. A lot of modern demos have made great use of the 8580, but I'm a little bit more old school and nostalgic, and I happen to prefer the sound that a 6581 puts out. And these boards are also famous because they usually came with the 6581 R4AR. And generally speaking, as far as 6581 SID chips go, these are considered to be about the best of all of them. So if you're a SID chip maniac like I am, these are definitely a board to keep your eye out for. So anyways, on to the next board. Alright, this is the next board up on the bench. This particular one, as you can see, is a Revision 250469. And the first thing you'll notice right away is, wow, this is a lot different. And indeed it is. This is the first revision of the so-called C64C shortboard. As far as I know, these boards were only in the flat white C64C model computers. These are also in C64Gs as well, and I happen to own one of those as well if you've seen some of my other videos. But anyways, you can see a lot of major differences to this particular style board, and there's a lot of things to point out. First of all, your keyboard connector has been moved way over here. You still have your same bridge rectifier, your fuse, you know, everything else. This is all pretty similar as far as the external ports, but they really changed a lot of stuff on this board. Your CIA is all the way over here. This is CIA 1 that handles the keyboard and joystick ports. Your second CIA has been moved all the way over here to this side. This CIA handles the user port and the serial port. Your CPU has been moved here. So basically working from left to right, you've got your CIA number 2, your character ROM. This is a basic and kernel ROM combined into one chip. These exact same chips are also found in Commodore 128s as well. You've got your 2 4464 RAM chips, just like the board I just showed you previously. You've got an 8500 CPU. This big chip here is known as the Super PLA. And something to note, here's your color SRAM chip. This is a 2114 SRAM, and it's directly next to the Super PLA. The Super PLA integrates the functions of the original 906114-01 PLA chips, as well as some other functions. So a lot of the extra glue logic from the board has been all integrated into this one great big chip here. This is your VIC chip here. Here's your 8701 clock generator, and here's your 8580 SID chip. As you can see, Commodore achieved a fairly monumental task here in integrating a Commodore 64 with all of its many TTL logic chips down into something much smaller and more manageable. This board is physically the same width as all the other boards that we've seen up to this point, but it's a lot narrower, which is why it's known as the short board. So yeah, it's a pretty interesting board. These are very compatible boards as well. You would expect some minor incompatibilities, but as far as I know, there are no real major incompatibilities between the older style Commodore 64 boards and this one. Anything that there are, any differences that there are very, very minor. So basically that's a C64C short board. And then I got one more board revision for you, and that's going to be pretty much the end of this video. Alright, this is the last board revision that I have for you. This is also a 250469. This particular board, though, happens to be a Rev B. Now, I'm a collector from the United States, as I've mentioned before, and these particular revision boards are very, very rare in NTSC form. I actually only have one 64C that contains this revision motherboard. But as you'll notice, this motherboard generally has the exact same layout as the one we just seen. To my knowledge, there are only 4 revisions of the 250469. There is the Rev 3, which was the first production board anyways. The Rev 4, which I don't know any major differences between that and the 3. It's probably the location of a few components. As best as I know, the schematics are exactly the same. There is the Rev A and the Rev B. Now with these Rev B, you'll notice the Super PLA looks a little different and has a different part number. The only major difference between this board and the one I just showed you is that you see the color SRAM now that used to be right here is gone. The color SRAM has now been integrated into the Super PLA chip. Now something I should mention is that in all of the 64C boards like this that I've ever had to repair, it's generally something to do with CIAs, ROMs, maybe the CPU, and definitely the RAM. The older style 64C shortboards almost never have problems with the Super PLA. It's practically unheard of. But I have heard of reports of these later style boards that have the color SRAM integrated into the Super PLA, where the color RAM itself has gone bad. And that basically, you know, you have to exchange this entire chip. And over here, these boards being so rare as it is, you know, that's not really something, you know, that's not a part you're going to find on the market very easily. Now over in Europe, which is where this particular board came from, this is a PAL version board again, these tend to be somewhat more common. Because as I said, it seems like the 64C had a longer life on the market overseas than it did over here. So anyways, you pretty much have everything laid out exactly as it was on the earlier 250469. Like I said, the only real major difference was the integration of the color SRAM into the Super PLA as well. And you can see by this board, the date codes on this board's chips. The 43rd week of 1991, 42nd week of 91. This is a pretty late board. I think I've seen pictures of some online that have date codes as late as 1992. So it's kind of amazing to think that they were making Commodore 64s all the way from 1982 to 1992, and possibly even later. Commodore itself as a company basically folded in 1994, so it's pretty amazing that it held out on the market as long as it did. And I got this particular board from my good friend Adam over in the UK, because like I said over there, these are somewhat more plentiful than they are over here in America. So anyways, that's been my video about all of the revisions of Commodore 64 motherboards. If you have any questions or you want me to clarify anything, just go ahead and you know, type them out in the comments there, and I'll try to get back to everyone. So anyways, I hope you enjoyed my little video there, and have a nice day to everybody. Take care, and until next time, hopefully I'll come back with another video at some point. Alright, take care everybody. Bye.